My fabulous earth science faithful. This is Mr. Milks.
And this is Mr. Galvin.
Check it. We're going to do some test prep, right?
Absolutely.
All right. So I'm seeing this picture. It says I got a granite rock with cracks, and look, water has seeped into these cracks. Asks us which kind of physical weathering will be shown by this diagram.
It's going to be, where are we at here? B. Oh, just read the bottom. Gotcha. First time. All right. Liquid water seeps into small cracks. When water freezes, it expands and widens or enlarges the cracks. This form of physical weathering is called freeze-thaw, ice wedging, or frost action. And anytime you see a picture like this with rocks and ice, you know this is what they're probably going to be talking about.
So it's A, right?
Yes, it is A.
All right, good. All right. Which change in climate of a location will most likely cause the greatest increase in chemical weathering?
So chemical reactions occur fastest in warm, humid climates. Increasing the amount of precipitation in summer would increase the rate of chemical weathering. You need heat and water for these things to happen. If you don't have it, it's not going to happen.
That sounds like D to me. Precipitation in summer?
Yeah. Yes. Absolutely.
So that'd be D. All right. Base your answers on the following question below. Which type of weathering is most common at 5 degrees and average yearly precipitation, sorry, not participation, at 45 degrees or 45 centimeters? So this is one of those questions, can you read a graph?
Basically, yeah.
So I see 5 degrees down here. So we'll follow that line up. And then it says 45, which is about here. So when those cross, that's here, and this is in this slight frost action area. So literally, you just plot the 2 points, slight frost action. There we is. Pretty simple, straightforward, right?
Yep.
Okay, good. Next one. Which mineral would most likely be changed the most after placed in a container and shaken for 10 minutes? This reminds me of the abrasion lab we did with the sugar cubes, right? And were the sugar cubes hard or soft?
They were soft.
They were soft. So we're looking for something that's soft.
So kaolinite, it's a soft mineral. Pyrite, quartz, and magnetite are much harder. Kaolinite will break apart most or abrade as a result of the shaking.
And we got hardness here.
Yeah, I was about to say.
And then the density too helps, right?
And it doesn't even give you a numeric value for the hardness. It's just whether it's hard or soft.
Correct. And so 3 of these guys are probably hard, right?
Yep.
And then 1 is soft. So this is another one of those Regents games where 3 of the answers go together and 1 of these things does not belong. It's usually the answer that's 1 of these things does not belong.
All right. Which event is the best example of erosion? And go ahead.
Yeah, so this is, we're looking for erosion itself. So the stream is going to become deeper. The material that makes up the bottom of the stream is both broken down and transported, right? And then the bottom statement helps us too, right? Because breaking rocks apart as a result of alternating freezing and thawing, the dissolving of limestone chemical reaction, the formation of residual soil are all examples of weathering, not erosion.
Right.
So in your own words, what would you say erosion is?
So I always use the it's a story, right? Weathering breaks it, erosion takes it, and deposition leaves it. So it's, you've got your beginning, middle, and end. You start your journey by breaking up, you move somewhere else by being eroded, and then you finally come to your place of rest as deposited. That's the end.
All right, so I'm thinking erosion here is...
it's going to be C.
Deepening
of the stream
bed.
bed.
Deepening.
Yep.
Because it's rolling and moving.
Yep.
So the key part here is that it's moving. And it's easy to kind of get this kind of a question.
This is a tough one.
This is a tough question because it's the difference between erosion and all the different forms of weathering.
Yep.
So, okay, good. This is one of the main reasons. This question alone is one of the main reasons why I want to make this video.
It's
because it's tough. Like, and it's tough to explain. So I want you guys to have the ability.
All right. Which change at a particular location of the stream usually causes more sediment to be deposited at that location? Oh, it's not popped up. Basically, it's not following along. Anyway, so basically, anytime you see like this, the amount of sediment that can be transported is determined exclusively by its velocity.
So generally, stream velocity decreases when the slope decreases. We go around that bend,
Yep.
or the stream enters a large body of water. So it can't be increase the slope, decrease the stream width, decrease the stream velocity. That's right there, right?
Decrease the stream velocity.
Like it. That's
Slow it down,
That's
and things
it.
are getting deposited.
And it's going as if we can only go as slow as my computer right now.
Yeah, that's what's happening.
We have a small computer delay.
There you go.
I think our computer is as tired as you guys are. We will wait for the computer to catch up with us, and then we will continue on our.
Map below shows a river emptying into an ocean, producing a delta. Which graph best represents the relationship between the distance from the river delta into the ocean and the average size of sediments deposited on the ocean floor? Now, that's a lot of words for this one question. But basically, what it's asking you is what happens to sediment size as you go away from that delta? And as you move away from the delta, your sediment size is going to get smaller. It's going to decrease because all the big stuff's already been deposited.
Right, and that makes sense. I mean, the big boulders are going to fall out, or big particles are going to fall out first as it slows, and then the water slows, and then the little particles will go out farther. So this is going to be A. The average sediment is going to decrease as my distance increases. It's an indirect mathematical relationship. We got a lag, bro.
Mm-hmm.
You guys will just have to not bump and just follow along.
All right. Map represents a large stream or stream meander or bend. Arrows show the direction of stream flow. Stream velocity was measured at the surface, locations A, B, and C. So as the stream flows around a meander or bend, the velocity will increase towards the outside of the bend.
So in that case, that's C. So C should be the biggest, and
Mhm.
A should be the smallest. So when I'm looking on here, that looks like answer C to me. C is the biggest, and A is the smallest.
Yep.
Sweet. There it goes.
There you go. Answer C.
You have to forgive us with these technical difficulties. All right, so this cross section below is a V-shaped valley.
Yep.
Which agent of erosion is most responsible for cross-cutting or for cutting this V-shaped valley into bedrock? So V-shaped valley should trigger.
Yep. Running water. Rivers leave V-shaped valleys. Glaciers leave U-shaped.
And the nice thing is there's a V in river.
Mm-hmm.
So, I mean, literally, if you need to do that, you can. U-shaped valleys are formed, but those are formed by glaciers. So we need running water here. And it looks a little blurry the way it's blown up. So hope you can read that water. It should show up and then hopefully go. Because this lag is killing me, bro.
It's crazy.
Yeah. It's not doing well for my ADHD. Although, let's preview the next.
All right, what will be the most probable arrangement of rock particles deposited directly by a glacier?
Cool. Glacier, big rock or big ice.
Yep.
Grabs all sorts of stuff. There's big conjumbulation of material.
Yep.
Ice melts. All that conjumbulation is there, which leads us to unsorted and not layered.
Yeah.
Okay? No rhyme or reason.
Glaciers are messy.
Yeah, glaciers are messy.
So they don't put things back where they belong.
Well, no, they just leave them.
Right.
Sounds like some of our student bedrooms, I bet. Like a glacier went through. Just a mess.
You just left,
Okay, there we go. Hey, it's moving a little faster now.
Here we go. Which agent of erosion was primarily responsible for forming the long, narrow U-shaped valleys in the Finger Lake region of New York State? Oh,
Well, we
man.
know that from the last one, we know that U-shaped was glaciers.
Yep.
And there's going to be a bigger definition of glaciers, but we're going to do D, continental glaciers, for this as it catches up. Y'all can pause this and read this, but we know from our last one that it was U-shaped. Glaciers is U-shaped. There's no U in glaciers, though.
Now there's a C on its side, though. You can kind of
All
take
right.
that over to a U. I don't know. I wish there was a better way.
Yeah, at least there's a V in river.
Yep. Particles in a sand dune deposit are small and very well sorted and have surface pits that give them a frosted appearance. This deposit most likely was transported by, well, if you think about where you find sand dunes, don't normally find them with a lot of water. So that's going to kind of take out all the ones that involve water, ocean currents, glacial ice, that sort of thing. This is gravity and wind is going to be the culprit for our sand dunes.
There we go. You gotta start hitting these buttons sooner, so we can just pick up with the lag, right?
Yep.
We're getting there, though. Meanwhile, you guys are getting a good tutorial on how to break these questions down.
Yep.
Okay. Which process is shown in these diagrams? I see soil creep, debris flow, mud flow, rock fall. This is a lot of material moving fast.
Yep, moving fast, and it's absolutely just kind of pouring down the side of the mountain. Specifically, the one rock fall. What's going to cause that to happen?
Right. So this is mass movement.
Mass movement. Lots of stuff.
Lots of stuff all at once.
Moved by gravity.
As we wait for the next problem. Oh, here we go.
Bedrock of Grenville Province is generally thought to have formed approximately.
We need a reference table for this one.
We do.
And it's coming. I already clicked the button. It's coming, so you guys can see.
Yep. See here. Boom.
There we go. So we can see that picture up by Mount Marcy is Middle Proterozoic rocks, intensely metamorphosized rocks.
It's an orthosite.
Okay. And that will help us figure out as it flies off the screen now.
This is approximately 1,000 million years ago.
Right. So the answer will be D, 1,100 million years ago.
Some of the oldest rocks in New York State.
Which was part of one of our other labs.
Yep.
All right, next one's coming up. Same picture, which waiting for it to flip so you can see different, right? Which location have a surface bedrock consisting mainly of
Anorthositic rocks.
Anorthositic. I'm glad he said that first.
It's one of my favorite rocks.
Again, same reference table, same pictures coming up. You're going to see, and I believe it's going to be Mount Marcy.
Yes, because it's in the Adirondacks. So remember, the Adirondack Mountains are the oldest part of New York State.
And it does say Mount Marcy right there. So these two questions go right together. Nice. And we're waiting for the lag. Mm-hmm. This was going great.
Yep.
It was really going very smoothly, and then we got a lag. So here we go.
Which two landscape regions in New York State have the oldest surface bedrock? Well, I was just talking about one of them. If you can kind of memorize the fact that the Adirondack Mountains are really old, this is going to help you out a ton.
Sure. And then the highest, least, right?
Yeah.
Weathered, like they've been there forever.
They've been there forever.
So these are the two places here circled. Notice that approximate 1,000 years ago is those two spaces.
Mm-hmm. And then if you compare that to the map on the other page, which they're not showing, you can get the names of those areas.
Oh, that's coming, though. I do have that for another one.
Okay.
So this is going to be
the Adirondack
Mountains.
Hudson Highlands. Yep.
Hudson Highlands, all right. The other reference table he's talking about is coming up, I believe, to help us answer this or the next question, so we can see at least on the screen what it looks like. But it's the page before.
Yes.
It's the page 2. Yep. So here we go.
So on which type of landscape region are both the Susquehanna, Chesapeake, and the Delaware watersheds located? So if we're looking at that, You got to find those large words somewhere
Right.
on that map.
So Susquehanna. Whoops.
Oh,
And then this is the other reference table.
yep. So they were down there in the southern tier part of New York State. So
Down here?
Yep, Allegheny Plateau.
Okay. And as it goes away, which is going to just take a second to go, then we can see that down this part, the southern part of New York State is where that was.
Allegheny Plateau, and that is
Yep,
listed as a plateau.
Yeah, and here's the Susquehanna that he was in the right in the
Susquehanna, Chesapeake, Delaware.
Yeah. Oh, and there's Delaware down there. So there we go. So it was a plateau. Perfect. Well done. This should be our last question.
All right.
Which type of landscape region are both? Assess same two places. Oh wait, this is the same question.
Nope. It's just you got to catch up.
Okay, cool.
This next one's about the Genesee River. It's asking about
here we go.
Which watershed is the Genesee River located in?
And we know the Genesee's going to come right out of Rochester, which was there, which is here now. So it's right down through here.
Yep. So we got to look and see where the Genesee River flows into, and it flows into Lake Ontario. So I think that's going to be a big clue as to what watershed.
Yep.
It's going to be in.
That's going to be here now.
So it's got to be St. Lawrence, Ontario.
Yep, there you go. Lake Ontario.
Our water goes from the Genesee River to Lake Ontario, and up St. Lawrence Seaway to the ocean.
Right. So we just went over 18 questions for y'all. Help you break down, slash and trash, decode what the questions are really asking for. And hopefully you got some insights on to some questions that are going to help you.
All right.
All right.
Good luck, everybody.